How's it going, everybody? So this is a short clip from a 4-hour long lecture that I did talking about why you cannot make absolutist claims from health science research or exercise science research or any kind of research on dynamic human organisms. Whether that's health, nutrition, whether that's disease prevention, disease reversal, or even exercise science and how to gain muscle, gain strength, and stuff like that, as well as supplements, nootropics, and things like that, okay? So, first of all, you have to understand that scientific research in regards to human health and human organisms in general, it is not sufficient or adequate or possible to provide proof or 100% evidence of causation, okay? This is something that people can't accept or they just don't understand, usually because they've never actually taken a college health science course of any kind, or they just overlook that part of it for some reason. And also, obviously, it doesn't help that there's so many health experts on YouTube and on the internet, and doctors as well, just that you'll meet when you go for your checkups, who are dogmatic, and they talk as if there are absolute proofs that have been shown. A common phrase to exemplify this is when professionals say, the evidence is very clear, or it has been shown pretty conclusively, or something like that. Or even worse, it is a scientific fact that. Anyone who talks like that, generally, I can confidently say they're not academics, they're not researchers, and if they are, they're not speaking accurately, okay? The more undecided somebody speaks about a health science topic, most likely the more accurate they are. There is thousands and thousands of nuanced kind of sub-information in between every major subject, okay? It's not as cut and dry as butter causes heart disease, or the vegan diet will kill you, or, vegan diet will make you nutrient deficient, or something like that. There is so much information in between those lines that you can't just make a black and white statement, like a conclusive statement on anything, okay? You got to break down the types of research. You got to break down the types of, nutrients involved, biochemical processes, and it's much more a kind of like patterning of clues and evidence and stringing together all sorts of bits of information, while at the same time understanding that there's always more questions to be asked, but never conclusive answers, okay? But anyway, it's impossible to develop causation from human health science research or even, exercise science and training science, okay? And so there's a lot of reasons why. And it will take an entire hour to really explain thoroughly why and convince people who don't already know and understand this. But essentially, for example, in order to prove something like, let's just say butter causes heart disease, okay, or disprove it even, you would need like a human trial where you take at least 20 to 100 different humans from different genetic backgrounds, okay? Like, let's just say 100 humans from a certain genetic background and put them in a metabolic ward, like a hospital for 50 to 80 years, which is the common claim time that it takes to develop heart disease, okay? Let's just say 50 years, right? You need 100 humans to eat nothing, to eat a high butter diet, okay, for 50 years. And then another 100 humans to eat like virtually zero saturated fat at all, okay, and definitely no butter for 50 years, okay? So you take two groups of 100 people, one eating let's just say 2 sticks of butter a day, the other eating zero saturated fat at all. And you'd have to keep them in a hospital setting or a metabolic ward where you can control their exercise, their nutrition, and everything for like 50 years and see if heart disease develops more in the group who, ate 2 sticks of butter a day compared to the other group. The problem is that study can never be done. And instead, because like who the hell is going to stay in a hospital for 50 years or whatever and eat not do normal life? That's like their entire lifetime, like dedicated to science. Back before like the 1970s or whatever, we used to do studies like that on people with mental illness as well as people who were in prisons and military as well. Those are now deemed unethical studies, so they can't do human intervention trials like that. Instead, they rely on volunteer research, usually out of hospital studies, where they pay the subjects and have faith that the subjects in the study that are being paid to do so will follow the intervention according to the protocol. So, for example, you get, like if you've ever been to a shopping mall and you have those people walking around with clipboards and they ask you a bunch of questions like, how old are you? Have you like gone through menopause yet? Stuff like that. And then they ask you how much meat have you eaten in the last couple of years and whatever. And then they might pull you over and recruit you for a study with a questionnaire and pay you like $15 or something for it, right? Stuff like that. There's a lot of different ways it goes about. But those people will recruit you for a study based on your qualifications and how compatible it is with the study guidelines. And then, there's cohort studies or questionnaire studies where they don't even tell you to change anything, and they'll follow up with you like 20 years later. And, based on your, you'll fill out a questionnaire of how much meat you've eaten, how much butter you've eaten, whatever. And then 20 years later, they will follow up with you and ask you how much heart disease did you get and stuff. And they'll just kind of tie it back to the questionnaire that you filled out 20 years ago. And maybe they'll do a follow-up questionnaire. Okay. But they usually assume that humans' behaviors and patterns don't change very much over the course of a lifespan. So a lot of times they don't even do a follow-up questionnaire. And they'll just correlate the health outcomes back that you reported 20 years later to the questionnaire that you filled out. Sometimes they do questionnaires in between and just keep following up. But generally speaking, that's relying entirely on the participants' honesty and transparency with the questionnaires that they're filling out. So that, of course, is not very reliable, but maybe it is, whatever. That's a form of evidence that doesn't cause anything, but that's usually the first line of research that a lot of experts use to point towards, to back up the claims that they make. The second form of research that is, commonly used, and there's a lot of forms of research, but I'm just going over the more, practical evidence that we do have to draw from. They'll pull you into a study and via recruiting of a similar nature, and this one is a controlled intervention trial, and they will basically have you. They'll tell you, hey, we're trying to study the effects of a blueberry antioxidant extract over the course of 6 weeks. I need you to take this blueberry extract supplement every single day for 6 weeks. And we're going to measure your blood cholesterol and your behavior, your cognitive tests, your ability to concentrate and focus, and your intelligence and your IQ or whatever. And we're going to do a comprehensive metabolic blood panel right now. And then after 6 weeks, every day I want you to take this blueberry extract. After 6 weeks, we're going to test you again, do the same test we did at baseline, and then we're going to try to correlate that back to if the blueberry extract made any difference. And then, of course, they might also ask them on the initial baseline testing, do you smoke cigarettes? How much money do you make every year or whatever? How much, what health conditions do you have already and stuff? Sometimes they'll completely omit unhealthy people from a study like this because they consider things like, let's say if they smoke, they might be omitted from the study because smoking, we know, induces oxidative damage that the antioxidant effects of the blueberry that we're trying to study for, it might have an interfering effect. It might be a confounding variable. So they try to weed out confounding variables by removing people who have, that smoke or that, make under a certain amount of money per year, because socioeconomic status plays a role in health outcomes as well. If you have pre-existing diabetes or whatever, you might not qualify for the study, because we're trying to examine the effects of blueberry extract on healthy people, not people with diabetes. And so anyway, they try to weed out confounding variables that way. And then after the 6 weeks is over, they compare the ending result blood test to the baseline blood test. Now, 9 times out of 10, usually, these studies are about anywhere from 2 to 8 weeks in length, which is only about a half a month to 2 months in length that they're doing this intervention. It's entirely dependent upon what the study participants are honest about, and then all of the confounding variables during their day that these researchers did not ask about. So, for example, they could be eating cake and all this other sugar. They could be drinking sodas. They could be doing a lot of other things during that time. And a lot of times the researchers don't ask about this. They just assume that they're healthier because they're not doing smoking cigarettes and all this other crap that they already weeded out at the baseline. But at the end of the 6 week or however long it is trial, usually because it's such a short study, 9 times out of 10, they do not show us a clinically significant difference in the end testing compared to the beginning testing. Usually, because this is an actual study that was done on blueberry extract, there's a couple of them actually. Usually, you don't find statistically significant differences that are so high that you can confidently say, if I take this blueberry extract or whatever the study intervention is, then in the real world, I'm going to have like a noticeable difference. And this exactly is the reason why you'll hear so many medical professionals and doctors and people, experts insist that there's no supplements or herbs or things that actually work, and they'll just assume, well, all supplements over the counter are just bullshit and herbs are bullshit and whatnot. Because science is generally not powerful enough in its current ethical boundaries to really figure out, to really find meaningful differences or meaningful impacts from these types of study designs. We need a longer study. We need a more controlled study. And also, and so we need a longer study and we need more controlled studies, for one. But anyway, a lot of experts, they'll take these findings like this, and there's a lot of other ways that these studies can be done. For example, they take people who on a questionnaire at baseline said they eat like red meat once a week, right? And it's like a 2-month study where they add, I don't know, like 5 pounds of red meat a day. Actually, usually these studies would say, all right, we want you to add 3 more servings of red meat a week, and we want to see what changes. Okay, 3 extra servings of red meat. First of all, these people, even if you educate them, they won't have any cognitive remembrance of what a serving actually even implies. Secondly, and there's studies like this done where they say eat 3 or 4 more servings of red meat a week, and then we'll measure you again in 2 months. And and the thing is, 3 or 4 extra servings, okay, which is a typical advice in a study like this, that's hardly shit to see meaningful differences. Maybe you can prevent anemia with that much, and nutrition deficiencies, but, and they're like, we're going to see if this impacts your cholesterol markers at the end of the study, or your blood sugar markers, or, they have these arbitrary measures of like cancer disease risk, like mTOR pathways or homocysteine increasing, which is just a nutrient deficiency, usually of B6 or folate. Or B12. And basically, at the end of the study, they'll measure one of those arbitrary metrics that has never been causally shown to increase your instances of any kind of disease, per se. But at the end of the study, if these like arbitrary measures increase, then the conclusion of that study, at least in the abstract, will be adding 5 servings of red meat a week over a 2-month period can potentially increase your risk of cancer and heart disease via mTOR markers or blood homocysteine increase by 0.2%. So anyway, that's generally what they'll find, and it's like the protocol that they use in these studies, like 3 or 4 servings of red meat a day. That's like 4 ounces. That's like 4 ounces three times a week. That's nothing. And then at the end of the study, so a lot of times, so the thing is, if the study doesn't show anything meaningful, these researchers will not get paid or the study will not get published. So they'll literally fish around for any kind of statistically significant differences in data that they can find so they can publish that research and get paid. If researchers are not publishing studies on a regular basis, they don't get paid. Okay, first of all. So they're pressured to constantly be pushing out studies. Otherwise, they got to find another means of financial gain. So not only are they pressured to keep pushing out research, quantity over quality, but furthermore, when they do pump out research, there has to be some kind of information that is interesting enough for a journal of some kind to be interested in, to actually publish so that they can get paid. And so this is where you get into the hazy field of, modifying numbers and also throwing out data that is relevant to the overall, they might study butter and heart disease over and over again and not see any difference in heart disease, at all. And if they publish that, it would completely change the public's idea or the doctor's idea about, butter and heart disease or whatever. But they don't publish it unless it will provide some kind of profit. And a lot of that depends upon just the impact of that data on the journal that they're going to publish it in. But the other part of that is whoever's funding the research. It is true. It is 100% true. And there's been more and more articles exposing this now, like published in the British media journal medical journal, the British Medical Journal. The sugar industry, and their whole messing with the data to try to paint fat as a bad picture. That's old news, and then also the amyloid plaque theory of Alzheimer's. We're now finding out that the actual brain scans initially used to found all that research on appears to have been let's just say artificially created rather than actual brain scans. It seemed to have been tampered with. And then furthermore, recently the whole pharmaceutical industry and food industry has been basically exposed to funding fraudulent research, basically. And so the so-called fraudulent research, what it really is. So a lot of people, they make the mistake of being like, oh, they just falsified blood tests and stuff, and they just created data out of thin air, and that's not really how it goes. How it really goes is, so with meta-analysis as well as cohort studies and even intervention trials, you can just completely omit baseline blood tests, for example. You could take people who already have high cholesterol, let's say, already have high cholesterol levels on the blood panel. Not that means anything. And then they take them through an intervention trial, consuming lots of sticks of butter, and then recording their a blood test at the beginning of the study, and they're like, okay, your freaking cholesterol is, let's just say, total cholesterol is 250 nanograms per deciliter. and then 8 weeks go by and they eat a bunch of butter or whatever, and then their cholesterol's still 250 nanograms per deciliter on average on the mean. And like, okay, well, butter didn't raise your cholesterol levels. But the problem is this person has had super high cholesterol, let's just say, not that it means anything, for years, and they didn't include those baseline results. And they left out the information that is, well, once your cholesterol hits a certain threshold, eating more foods high in saturated fat and cholesterol doesn't increase it anymore. But the abstract, the study can be published as, well, but eating, 2 sticks of butter a day doesn't increase cholesterol, has no meaningful difference, and so that's just a way that they can, someone with pre-existing knowledge of the subject can omit very important information and certain test results and things, and make it appear that there's a certain effect from this intervention that there really wasn't. Secondarily, you can take like the blueberry extract, for example. This is actually something that's been done. And, it's like a 3-month study or whatever where they take blueberry extract and try to see differences in cognitive results or impairments or whatever. And after like the 3 months are over, they find very little real difference in like, let's just say cognitive ability from the blueberry extract. But and like in all the tests that they use, right? Let's say they did 100 tests. Only 2 tests that they actually tested on showed any like significant measurable difference on the cognitive test from the blueberry extract. They can just completely ignore like 80 of the tests that they did that showed no difference. And even tests that showed the blueberry extract made worse outcomes on the test. They could just remove that data completely and just ignore it, but just include the data that did show a difference to make it look like they only tested 10 different tests for the blueberry extract and showed like 2 out of the 10 tests that they included showed like a 2% relative increase in cognitive ability. But they don't mention the 100 tests that they did. They only include the data that is going to make an impact, that is necessary to make an impact and get them paid. And the 2% relative increase in cognitive ability that they showed out of the 10 tests they included, okay, out of the 100 tests they actually did, the 2% relative difference in clinical application in the real world only shows like a 0.2 absolute difference in cognitive improvements. And what that really means is that the study basically did jack shit. That relative differences in study participants, it could seem like, a 20% increase in benefits or a 20% decrease in risk of dying or something, right? And in the real world, that can mean very, very little, depending on all the other things. So anyway, these are just ways that study authors can kind of manipulate information. And so, yeah, it's like we're left with a complete, most people have no clue about all of this, okay? They hear 20% difference in risk, and they think, oh my God, I'm going to die if I eat meat or something, right? And then you look at it through a more accurate lens, you're like, oh, that doesn't actually mean a whole lot. So then you ask yourself, well, shit, like if that is if that's how powerful science is for health outcomes, right? You take, then how do I even like figure anything out? And there's a lot of other ways that this is present, okay? Obviously, you have population studies, and you see, I talk about this all the time. Just look up healthy user bias and population data, or epidemiology and healthy user bias, and you'll know what I mean. Look up the UK Shoppers study, and so let's see. So this is why. So the other thing, let's say strength training, okay? Almost always in exercise science, okay, most of these textbooks that we use, especially for personal trainers and stuff, the strength training programs that we use, Usually you take college students who are already sedentary and not really trained. They don't squat or deadlift or anything. They put them on a strength training routine. And then after 4 weeks, lo and behold, they get stronger on the exercise routine being studied. When you take sedentary individuals who have never trained before, their body will literally adapt to anything. And if their body does not adapt to a strength training program, well, then at least you know it's shit. Because taking a beginner in a strength training routine, let's say a 200-pound man who can't even squat 300 pounds, he is a fucking beginner. Because any decent strength training program should be able to get a beginner to be able to squat 300 pounds, who's a 200-pound man, within a matter of 6 months. That's how easy that really is. But most people have no clue. They're like, oh shit, I squat 300 pounds. I'm an expert now. Walk into a Gold's Gym and think they're badass. Well, not anymore. Gold's Gym is a serious gym these days, but in LA Fitness, more so. Gold's Gym is badass, actually. These days, we completely changed the branding. It's a serious training gym now. But anyway, so if you're a 300-pound squatter at 200-pound man, you're still a novice walking into Gold's Gym. But anyway, they take sedentary individuals who never trained before, and then they put them through a strength training program, and they're like, okay, well, that means my 5x5 program is the best program, and and so they try to draw like volume landmarks, percentage of 1 rep max and intensity zone landmarks, or whether or not you should train to failure. And they use these studies on sedentary individuals or people that they claim are trained. They're like, okay, these are pre-existing trained athletes, and we put them through a strength program. And they got results on this. Or they got, we found that 10 sets of 10 at 70% of your 1 rep max is enough volume, is a volume sweet spot, or is the intensity zone sweet spot. And the problem with that is the researchers' criteria for trained athlete is completely subjective. We don't, like most of the time, the researchers who say, oh, this is a elite level athlete, they're not actually that trained in strength training. So it still is questionable. The other thing is, in strength training research, there's a lot of information that the average person doesn't know that is necessary to understand the outcomes of the study. So, for example, in strength research, any kind of exercise program, okay, the intention is to adapt a trainee to a stimulus. The problem is, how adaptable your body is to a certain stimulus depends entirely upon the training program your body's already adapted to. So if you take a person who's already been doing a 5 sets of 5, a 5x5 strength training program for a year, their body's already adapted to that 5 sets of 5 program. So that means that their body is already pretty desensitized to it. They have such a high tolerance to training at 5 sets of 5 that if they are put through another 5x5 program by researchers, their body's not going to be very adapted. It's not going to get very good results from the program because it's already been adapted to that program for a year. But what happens if you take those same people who have already been training 5x5 for a year and you put them on 3 sets of 10 for 6 months on the researchers? What you'll find is, because their body's adapted to 5 sets of 5, now they're doing 3 sets of 10. That's a completely different training stimulus that they're not adapted to yet. And so they're highly sensitive to it. They haven't built up an adaptive resistance or tolerance to that training program yet. And so they're going to adapt. And so this is a problem in strength training research. Strength training research doesn't take into account this, doesn't include these things in the study. And so the average person, they look at the research and like, oh shit, like the volume sweet spot is, around 25 sets per body part per week or something. It says so, it's evidence-based. But the reality is, most of the evidence that these evidence-based recommendations are based upon, there's so many flaws that most people are not aware of. So, can we really use scientific research as a baseline to help us understand where to go? And these problems lie in all of our recommendations, from our needs to vitamin C. I've made a whole video explaining why our understanding of nutrient needs, vitamin needs, fiber deficiency or fiber needs, and all that stuff is completely debunked. I basically explained why the government's, RDI or recommended daily intake is highly questionable. Why you should not be obsessed with getting your RDI. I made a whole video about that, explaining that in detail. But all of nutrition science is founded upon the same kind of scientific fallacies that the RDIs are based upon. We really don't know how much vitamin C is necessary, and even if we need to be getting vitamin C from fruits or something, we don't. And the carbohydrate research too. Almost all of the research showing that your body burns, purely carbohydrate at a certain intensity zone versus beta oxidation of fatty acids for ATP. Almost all that research that shows things like that are done on humans that are already adapted to eating carbohydrates most of their life. They've been eating pounds of spaghetti every single day for, decades. And then they expect to see, they're like, oh shit, well, when you exercise at, past 90% of your VO2 max, your body's using almost entirely glucose, and it can't produce enough ATP from fatty acids at past 90% of your VO2 max or whatever. So therefore you need carbs to fuel that energy system. Well, the fact is there is research. There's actually a new study that was published in January of 2023 showing this. There's a whole lecture from Stephen Finney and Jeff Volek explaining this, that athletes who spend a number of months adapting themselves to a low-carb protocol can actually produce energy from fatty acids at, double the amounts. But the common dogma is all seen through the lens of carbohydrate-burning research, carbohydrate-adapted humans. And they're like, well, look at this 2-week study on competitive race walkers where they go on a ketogenic diet and they see a significant decrease in performance. That's because we know the body can only use glycogen for exercise performance and blah, blah, blah. You need to eat carbs to fuel that energy source. So I made in-depth videos on that too, because again, all these subjects take a whole hour at least to debunk or to explain thoroughly. Most people don't want to believe it. They don't have the patience. They don't have the time. And they're already emotionally attached to, the dogma that has been fed to them their entire lives. That they don't have the patience to watch a whole hour-long video on why you don't need carbs to train effectively, or at least it's possible that you don't need carbs, or that it's possible you don't need to eat fiber for healthy bowel movements. Like, but if I don't eat my oatmeal, I can't poop. It's like, well, there's a lot of reasons why that's probably true, and if you just, but they're like, no, it's, fuck that. It's, I've already found the facts. Or like, if I don't eat my damn, 5 oranges a day, I'm going to have a vitamin C deficiency. It's like, actually, that might not actually be true. Whatever. Yeah, so, or if I eat red meat, I'm going to have cancer. It's like, probably not, maybe not. So anyway, basically what this video, the main point is, it's not that science is useless, okay? Again, if you think that that's the point of this video, then you completely miss the point. The point is, scientific evidence is not adequate to prove causation or solid, cause and effect statements. It's not for health outcomes, for exercise science and stuff like that. You have got to keep an open mind, and you've got to understand these people who are reversing autoimmune illness on carnivore diets or whatever, okay, to ridicule them because you're like, oh no, the science is pretty clear that you need vegetables. It's like not a scientific or a healthy or an intelligent thing to say, but you think it is. You're like, oh, the science is certain. These people are quacks. It's a fad diet. Rah. Like, that's an emotional response. It's better to actually be like, to look at, to examine these people. You got to understand there's hundreds of people who are healing themselves on that diet. The point is, we need to keep an open mind, even with things like raw veganism and stuff. Okay, it's okay to be to have your opinion that, oh, they might be hurting themselves, but to make ad hominem attacks and personal attacks and say these people are stupid or whatever, it, for one, is bullying. It really is. A lot of these people are suffering from really hard diseases that modern medicine couldn't help. And you're like, oh, they're all stupid and quacks and fad dieters and stuff. You're just being a hostile and bitter human for no reason. Just because you feel morally superior because you think that you're following a more intellectually superior paradigm, which I do have 149 IQ in the second grade, or I did. Probably knocked down quite a few points now, right? All the blows to the head I took in kickboxing. But, you know, I'm not by, you know, any real standard a dumb person. A lot of people are just emotionally attached to their ideology, and therefore they make Dunning-Kruger, and they assume the other people are the Dunning-Krugers, right? Or people who think, let's say in exercise science, training to failure is stupid or is wrong. It's not an intelligent statement to make because there's individual differences based on genetics, where some people can train to failure and get way better results than others who train with reps in reserve. The problem is when you say all people who follow carnivore diets are stupid, or all people who train to failure are stupid, or whatever, or this is the best method per se, right? And let's see, what's the other thing? And to say like, oh, freaking antioxidants, you need them, polyphenols, you need them. To make generalized statements, the research is clear that saturated fat causes heart disease, or veganism is unhealthy and nutrient deficient, or whatever. They can make educated statements regarding that, but to make generalized cause and effect statements, or generalized statements that this is probably the best thing for everyone, or whatever, that is where the problem lies. Okay, the problem lies when you make cause and effect absolutist claims. And you say the research is clear, there's a scientific fact. If you eat meat, you're going to have cancer. If you need fiber, if you're not eating fiber, you're going to have constipation or whatever. Or everybody, you need vitamin C in your diet or else you're going to die of scurvy or whatever. Or even like you need to eat, 3 grams of protein a day or you're going to die or some shit, whatever it is. The better thing you can say is, from my observation, from my experience, the totality of the evidence seems to suggest, 1 gram of protein per pound of ideal body weight is probably optimal for health and longevity and building bone mineral density and muscle mass and neurotransmitter health. Like, that's an example of a, open but helpful and productive representation of the research. But extremist people, like, especially in the comments, who are like, no, like, freaking all that protein's going to cause cancer, or like, research shows 0.8 grams per kilo of body weight is more than enough, or like calling someone a quack because you think that your representation of the research is better. It's the absolutist claims, it's the extremism, it's the anger at people who believe something different than you. That needs to be completely removed from the discussion, okay? Because in reality, health science is not in any way, shape, or form adequate or full-powered enough to be able to make those types of claims. So anyway, hopefully this made sense. Or to say, all of those supplements are just bullshit. They're just quackery. There's no evidence that they even work. It's placebo. Those people healing themselves with fibromyalgia on carnivore diets is placebo. Those people who take holy basil to resolve their anxiety is placebo. People who eat healthy and exercise and they find it resolves their depression, well, that's great that you placeboed yourself. Like, I hear this shit all the time. It's like, no, you're not helping anyone by these types of things, these types of claims. Like, it's placebo because there's no research or whatever. You need to take my Ritalin for ADHD. No fucking exercise can help. If you exercise or took a supplement and it helped your ADHD or resolved it altogether, then you never had ADHD to begin with. You have to take Ritalin, you're doomed for life. That's the criteria of whether you have ADHD or not. These people say shit like that. And it's like, little did they know the pharmaceutical, the evidence on these pharmaceutical drugs that they think are the golden standard. These clinical trials generally show just the same level of evidence that a lot of these supplements do or diets do, but they don't realize, they don't understand science. They just understand what experts tell them, and they repeat that shit. So anyway, I'm not saying pharmaceuticals are bad or ineffective or anything. I'm just saying what you think is good evidence a lot of times is not as good of evidence as you thought. And it's okay to believe that the evidence you're using is good or bad or decent enough, but when we make claims, that's where the line in the sand needs to be drawn, okay? The more extreme the claim, the more extreme the evidence needs to be, and 9 times out of 10 it's not there. So leave your questions and comments down below, and I'll talk to y'all next time.